Okay, our second set of examples is going to be from comparing the exams that we had, that exam data. So we already used that exam data before, basically to find like the mean and a confidence interval for each exam for like the mean score. And then I did compare one exam to another to try to say whether the next exam was harder, but that wasn't really the appropriate test to use because we were taking scores from the same students. And like you use the two sample t-tests if there's not really any comparison between the two sets of students. Like we give one exam to one group of students and the other exam to a completely different group of students. And so we can't sort of compare a particular exam one to a particular exam two. But in the data that we were using, like those were two different exams taken by the same student. So if an exam was harder, then all the scores should go down, or most of them should go down. If the mean went down, but some people got higher scores and some people got lower scores, then maybe it didn't indicate that the exam was harder. Maybe there was just a couple people whose scores went down a lot. So it would be more appropriate to use a paired t-test to see how much did each student's score change. Did they all sort of go down by kind of similar amounts? Then yeah, the second exam was definitely harder. Was there a lot of up and down? Then maybe it was just a very different exam and not necessarily actually harder. So let's compare exam one and exam two using this paired t-test. Okay, so I need to bring up my data from the old exams. So I have this in the file from a few days ago. So there's my exam data. We'll load this up. And so like this up here, this first student got 44, then 43, then 48, then 40. There were students who did a lot worse on the second exam. Like the next two students, their scores dropped by like 10, 13%. And I don't know that there's many examples of students whose scores went up. It looks like they mostly stayed the same or went down. This student went up by 3%, but then there's this one went down 23%. That's a big difference. I keep having to fix this data because I should have fixed it in the original file so I don't have to keep changing these zeros to blanks. Okay. So let's do a paired t-test comparing exam one to exam two. I want to know if exam two was significantly harder, but using now the more appropriate test where we can compare each student's before and after and see how their score changed. So basic statistics, paired t-test. Sample one is exam one, and sample two is exam two. Okay, why don't we do a histogram here? I didn't do that before. It might be an interesting thing to see. So comparing exam one and exam two, the mean on the first exam was 43, the mean on the second exam was 36, which is much lower. But now what we actually care about is what was the mean drop in score. So it looks like it went down about 7 points. Okay, so the mean change was 6.8. Standard deviation, also about 6.8. We still get a very small p-value though. So very small, like down to like the 9th decimal place, we definitely have strong evidence that there is a difference in difficulty between these two exams. So looking at our histogram here, it looks like, so these are the people whose scores like were actually higher on the second exam. These people are the people at 0. They got basically the same score on the first and second exam. I don't know how wide this bin is. It might include people who like gained a point or lost a point. But then look at all these people whose scores went down. And there was a lot of people who lost 10, 12 points. So this is at 12. So a lot of people who lost 11, 12, 13 points, and then a few people who lost more than 20 points. And so, yeah, so most of the people, this is the break-even line. Most of the people are in the score went down, and they went down quite a bit. So the second exam was a solid chunk harder. But why don't we compare to the third exam? Like people's scores on the third exam, some are lower, some are higher. Actually, like there's sort of like more that are higher than are lower. There's definitely some lower and some higher between the first and third exam. So let's rerun this test comparing the first and third exam and see if there's a difference there. Whoops. Get rid of that one, compare the first and third exam, see what we get. So the means are pretty close here, 43 and 48. But maybe the second exam, so it looks like the second exam was a little bit easier, but if everybody's score went up by 1, that would still be a statistically significant difference. It would just be that the difference was that it was a little bit easier. But if some people went up and some people went down, then we'll probably find that there wasn't a statistically significant difference. And the p-value is not that big, but 0.137, that's bigger than 5%. So the null hypothesis could definitely be true that they have similar difficulty. Now let's look at our histogram of the differences. This little dot is at 0. A lot of people had the same score between exam 1 and exam 3. A bunch of people had higher scores. A bunch of people had lower scores. Like I said, if everybody was like a little bit better on exam 2 than exam 3, or I mean, if everybody was a little bit better on exam 3 than exam 1, sorry, then, and like everyone was sort of piled over here, like solidly to the left of like the 0 line, then that might be called a statistically significant difference. But when everybody's sort of like all over the place, then we say like, well, down to randomness, like there's probably not much difference between these two exams. And you can see this bar here, that's our confidence interval, and it includes the null hypothesis number. So when that happens, you're not going to be finding a statistically significant difference. All right. I think that's enough here. Like you get the idea of the paired t-test. It's only appropriate to use if you have two sets of numbers from the same subject or some reason why like one number from the first group goes with this number in the second group. And it makes sense to say, well, how far apart are those two numbers? Like that's what we care about. So weight loss or exam scores, did your exam score go up or down? Like, did you gain or lose weight? You know, like basically like two measuring the same person twice on the same type of thing. Or the same object twice on the same type of thing. That's when you use paired t-tests. You can compare like a before and after, or situation 1, situation 2. If the stuff in your two groups aren't related in that way, then you should be using two-sample t-test instead. Okay, I think that's enough for today. And we'll move on to how to compare more than two groups of number data next time.